Hi, welcome to our next lesson, which is 6.3, Intro to Trigonometry. The objective is identify trigonometric ratios and use them to solve problems. Trigonometry comes from the Greek word trigonon and metria, meaning triangle measurement. The study of trigonometry has been used for thousands of years to study the relationships between the sides and the angles of right triangles. So we're going to be doing an intro to trig and learning about the ratios that you will see in the triangle. What is a trigonometric ratio? A ratio. So basically there are two ratios of two sides of a right triangle and a related angle. We will do examples based on that. So there are three angles in the triangle, and then that angle in between the two sides, there's a relation between those two. So depending on which angle you use and what two sides that are next to them, that are adjacent to them, will determine what ratio you are dealing with in order to find the angle or the side or whatever it is. The three most common trigonometric ratios are sine, and you usually see with a sine, and that theta symbol is theta is a Greek symbol meaning angle. There's cosine angle, and tangent. And when you are looking at it in the diagram itself, you'll see you have a right triangle, and there's three angles, and one of them always have to be the right angle, which would be 90, and then you have the two other angles. So as you can see, based on how things are labeled, if I were to look at the blue angle, which is C, the side, whatever is next to that angle, is adjacent. If you heard the word adjacent, that means next to. So the side next to the C angle is considered as adjacent. And the side that is opposite that angle, the C angle, the blue one, is opposite. Makes sense. Now, if you were to look at the B angle, the side that is next to it will be adjacent. So this side now, AB, is adjacent. And then what's opposite is the 15, AC. So again, it makes sense. So anytime the angle that you are focusing on, that you need to find what the measurement is, see what side is next to it and what's opposite. Then that will determine what's opposite, what's adjacent, based on that angle that you're working with. And the last side is the hypotenuse. So it's always opposite the right angle. So once you know where the hypotenuse is, then you can figure out, okay, what's my opposite side of the angle that I want to deal with and what's adjacent to it. So we have definition. So I'm going to make this bigger. Oops. Do that again. And make this bigger again. And bring it down. All right. So the definitions for sine, cosine, and tangent. Sine angle is opposite over hypotenuse. With cosine, it is adjacent over a hypotenuse. And tangent is opposite over adjacent. And if you were to look at the angle above, the diagram above, if we're doing the green one, so that's B, angle B is green. So for sine, since sine is opposite over hypotenuse, we have opposite 15 over the hypotenuse, which is 17. For cosine, it's adjacent over hypotenuse. So for the adjacent, it's 8 over hypotenuse, 17. And tangent is opposite over adjacent. So we have 15 over 8. And if you were to do it based on the angle C, then you would have, for sine C, it would be opposite over hypotenuse. So you have the opposite, which is 8, over the hypotenuse, which is 17. For cosine C, would be adjacent over hypotenuse, so you have 15 over 17. And for tangent would be opposite over adjacent, which is 8 over 15. So that's the three ratios, common ratios that you will see when dealing with right triangles. And in order to remember those ratios, I'm sure you've heard of SOHCAHTOA. And you may have heard it in middle school in order to remember what goes with what. So SOHCAHTOA. For so, it's sine opposite hypotenuse. Ka is cosine adjacent hypotenuse. And TOA is tangent opposite adjacent. So if it's hard for you to remember which angle goes, which sides deal with whatever angle, then SOHCAHTOA, you can never go wrong with it. So that way you know that each letter, the first letter, will represent what the word that you're dealing with. So SOHCAHTOA. Always remember that. Can't go wrong. Now, we're going to use an example based on this diagram to find sine, cosine, tangent R and sine, cosine, tangent S. I've highlighted everything. Everything's color-coded, so that way it's easy for you to follow. For sine R, the R angle, it's in blue. So I already labeled it. So since it's sine R, not sine R, since we're dealing with angle R, I'm looking for the adjacent. So the side adjacent is adjacent, that's 3. Opposite it is 3 root 3. And the hypotenuse is opposite the 90-degree angle. Okay, so let's do sine R. Sine R, as we can remember, SOHCAHTOA, so it's sine opposite over hypotenuse. So then that means we would do 3 root 3 over 6. And then we find the decimal for it. So, okay, the next one is cosine R. Cosine R is adjacent over hypotenuse. So adjacent, it'd be 3 over 6. And when you put it into decimal form or fraction, decimal, it would be 0.5. And for tangent, it's opposite over adjacent. So TOA, T-O-A. So that will be 3 root 3 over 3. And then when you do the decimal, it gives you 1.732. All right, so we've got the angle R, and it's all the three ratios. Now let's go for angle S, which is the magenta. So first I've labeled it, the side that's adjacent to, that's near the sine angle, the S angle, is adjacent. And what's opposite from that angle is, opposite, 3. And then the hypotenuse is still opposite of the 90-degree angle. So let's look for sine S. Again, SOHCAHTOA. So it's sine opposite hypotenuse. So then we have 3 over 6, gives you 0.5. Cosine, that would be Ka. So it's cosine adjacent over hypotenuse. So we have 3 root 3 over 6, which gives us 0.8660. And tangent, which is for TOA, it's tangent opposite over adjacent. So that will be 3 root 3 over 3 root 3 over 3, which gives us 1.732. So I've got all this ratio for angle R and angle S. Now when you look at the numbers, the fraction or the decimal, what do you notice? If you said a few things, you might say that tangent R and tangent S are the same. Yes. And then when you look at sine R versus cosine S and cosine R versus sine S, you notice that they have the same number. So again, this is how the triangle works with the ratio. If you do one angle, there's always a connection. If you do one angle, then the opposite of that will show up. So sine R give you the complement of sine S, sine angle. So S and R are complement of each other, complementary of each other. Now, you're trying to say complement. What do you mean? Do you remember when we did supplementary and complementary angles? Complementary angles occur when you add two angles and you get 90 degrees. So sine R, this angle, sine R, compared to, compared to sine S, they're complements. Because if you had this as 30 degrees and then 60 degrees, that gives you 90. That's a complement, complementary. So that's why these numbers, the way they're working out, where you have the opposite, because they're complementary. And with tangent, it just deals with the 90 degree angle, and it's a ratio versus ratio related to the 90 degree angle. That's why they're both the same. But with the sine and cosine, they're complementary of each other. That's why the numbers that you see are switched when you have to do for one angle and then for the other. All right, let's go on to the next one. Now, there are times when you're going to have to find the sine, cosine, tangent of an angle, and unless you are really good at memorizing, they have a table of all the decimal numbers for all the angle measurements and their ratio. But unless you are that great with that, you can always use a calculator. So there's 6 different examples, and before we even go to that, some of you may know what to do, but again, a refresher does not help. Does not hurt. So with your calculator, you would make sure the first thing you would do is press the mode button. So that's the one I boxed in blue. You press the mode, and when you press mode, you will see this window. Make sure that the degree word is highlighted, because when you have to enter your information, you don't want your answers to come out in radian. There will be a time and place when you need to use radian, but since you want to get the degree measurement of what's given up here, make sure it's highlighted on degree. Once you do that, you press second and mode to get out of that screen, and then you press either sine, cosine, or tangent based on what the question is asking you. So if it's sine, whatever it is, then you press sine, and then you would enter the number, and then once you have that, you press enter, and it will give you your decimal degree, your measurement for that degree. So let's try this out. So I'm going to be using my calculator. So it says sine 40. So I press sine, and then I enter 40. I press enter, and then I get point. So let me write that with blue. I get 0.642, and then let's see, 4 decimal places. Okay, so then 4, 2, and then 7 and 8, so I'm going to round it to 8. All right, so I'm going to do that for cosine. So cosine 43. Press cosine 43, and then I get 73135. Since I have to round up, I'm going to have a 4. And then same for cos 77. I get 0.22, and it says 495, so I'm rounding up. It's going to give me 50. Then I do tangent. I press tangent 85. It gives me 11.43005, round up to 1. Then sine 10 degrees, which will give me 1.1736. And then tangent 24, which will give me 0.4452. All right, that wasn't too bad. So again, be careful. Make sure when you have to find the degree measurement for your ratios that you are in the degree mode, not radian. All right, so let's move on. All right, so now we're going to use what we learned about the ratio, the trig ratios, and apply it to these questions. So for this one, it says, let the sides of a right triangle be 8, 15, and 17. All right, so I'm going to mark up what I need to mark up. And this is a triple. This will give you a right triangle. So these 3 numbers that we see, the 3 sets that we see, these are triples. And the only way to know them, if you actually memorize some of the basic ones, especially 3, 4, 5, then you'll know that it's a right angle, and then you could do what you have to do. So I'm going to put my little right angle marker. This will be 8, this will be 15, and this will be 17. Again, you remember when it comes to your 3 numbers, the 2 smallest numbers will be the legs, and the biggest number represents the hypotenuse. All right, so it says find cosine of the smallest angle. I don't have that little recorder bar blocking it, but it's angle. So I know I need to find cosine. So cosine, I know it's ca. So that means cosine would be A over H. Now I need to know what's opposite, what's on hypotenuse, and all that stuff. So let me label that. So I need to find the cosine angle. So whatever the angle is, this would be my angle. So this would be the adjacent because it's close to the angle. So that's adjacent. This is opposite. It's on the other side. So it's O. And then this is opposite the right angle. So this is H. So now I'm going to plug in my information. So it'll be 15 over 17. And then I think I already found it. So let the sides of that, find the cosine. So now I'm going to divide the number, 15 over 17, and then I will get 0.8824. All right, so there we go. Let's do the next one. And just to let you know, when the smallest angle, based on the sides, so since this angle is opposite the smaller side, that's why I set it up in order to find the smallest angle. So if it was the other way, 15 is bigger than 18, so that would not be the smallest angle I'm looking for. So remember what we learned about smallest angle? The opposite, what the side opposite it is going to be small also. All right, so for the next one, it says let the sides of a right triangle be 3, 4, 5. We all know that that is a right triangle. Put the 2 smallest sides for the legs, and the hypotenuse is 5. And then I'm going to label it. So it says find the tangent of the smallest angle. So now this 3 is smaller than 4. So then that means the opposite angle is going to be the smallest angle. So I'm going to highlight that one. So that means this is opposite, this would be adjacent, and this is my hypotenuse. And then since I'm looking for tangent, TOA, so then that would be T equals O over A. And then just plug in the correct information, 3 over 4. And then you can leave it as a fraction, or if you want to turn it into a decimal, in this case, so it'll be 0.75. And then let's go on to the next and last one. We've got 7, 24, 25. We need to find sine of the smallest angle. So with that one, I will use blue, and I'm going to label it. So this will be my 2 smallest numbers will be the legs, and then my hypotenuse would be 25. And of course, I'm going to label it. So this will be, that's the hypotenuse. And then again, they say the smallest sine angle. So that means the opposite, the 7 is the smallest, and the opposite will be the smallest angle. So I'm going to work off of this. And then going to have adjacent because it's closer to the angle, and this one's opposite on the other side of that angle. And since I'm looking for sine, it's going to be so that's S over equals opposite over hypotenuse. And that'll be 7 over 25. Yep. And then you would have that, and then you could put the 7 over 25 0.28. All right, there you go. So you were able to figure out, well, work together to find out the cosine, tangent, and sine based on knowing where to place your ratio, your numbers based on the ratio, and then find what you need to find. Right, so let's do, I think this is the end of that one. Yep, so let's do a recap. We learned about trigonometric ratio. So basically it deals with the angle in between two sides that will show some kind of relation. There's three types of trig ratios that you've learned, which is sine, cosine, and tangent. And when you have to set them up, the definition, sine is opposite over a hypotenuse, cosine is adjacent over a hypotenuse, and tangent is opposite over adjacent. And if you cannot remember that right off the bat, SOHCAHTOA is a mnemonic device that you can use in order to remember what cosine, what trig ratio you're using, and what are the sides that are related to that angle. So SOHCAHTOA. And also, when it comes to using the calculator to find the measurement of an angle, make sure that the mode is set to degrees, because if it's in radian, you're going to get a totally different number that is not accurate to trying to find the degree of that degree measurement of that ratio. So remember that. And all you got to do is plug in pressing sine, tangent, or cosine and the number, and then that's it. Right, so if there are any questions, don't hesitate to email. I know this was a shorter lesson, but it's all about SOHCAHTOA. Right, have a good day.